So we're in section 5.3 now. This is driving me crazy. Let me do this. Yes. When we're done with notes. All right, enough. So we are going to talk about slope-intercept form today. And slope-intercept form, all the stuff we talked about in chapter 5 has to do with linear equations. Linear equations model linear functions. And that means that the graph of the equation that we're talking about would look like a line. Slope-intercept form. So I'm going to say the graphs of linear equations usually cross the y-axis. So when we have a linear equation, usually it's going to cross the y-axis unless it's a vertical line. Then it doesn't cross the y-axis. The point where it crosses is called the y-intercept. So I want to emphasize that the y-intercept is a point. So a point, we use parentheses and two numbers. At the y-intercept, x equals 0. So on the y-axis, on our graph, the x-coordinate is 0. X equals 0 at the y-intercept. So our slope-intercept form for the equation of a line, it's a one that we're probably the most familiar with, and we've talked about it already. Is y equals mx plus b. Where m is the slope and b is the y-intercept. Now, b is just one number. So we'll talk about how we get a point from that y-intercept in just a second. So when we have our equation, y equals mx plus b, m is the slope, b is the y-intercept. Slope, rise over the run, y over x, rate of change, all of those ways that we've described slope. So this is our big idea for today. Slope-intercept form tells us the slope of the line and where it crosses the y-axis. And when we have those two things, really we have everything we need to know about a line. So I just want to go through some examples of different ways that we're going to kind of pick out information about a line from its slope, from its y-intercept, from its graph, from a table, relating back to this equation. So we're good so far? Okay. So we'll start with a nice, easy example. So we want the slope and the y-intercept of the line, y equals 3x minus 6. Well, when we have our equation written like this should be pretty easy. This is the slope. And the y-intercept is the point 0, negative 6. The y-coordinate is negative 6. The x-coordinate at the y-intercept is 0. A lot of times we think of this as y equals negative 6 for our y-intercept. But I want to emphasize that the y-intercept is a point on our graph. It's not just a number. All right, questions there? Well, let's go the other direction. We want the equation, or an equation, of a line with slope equal to negative 1/5 and y-intercept sorry, my computer's going really slow, so writing is having a hard time keeping up. Y-intercept of 8 might be how the problem is described. Well, this is the slope. So that is m. And the y-intercept is b. M equals negative 1/5 and b equals 8. So my equation is y equals negative 1/5 x plus 8. So I just put the m, slope negative 1/5, b is 8. And we're done. There's my equation. So when we know the slope and the y-intercept, we know the equation. When we know the equation, we know the slope and the y-intercept. And we can think of this 8 meaning the line crosses the y-axis at the point 0, 8. All right, so questions there. Slope-intercept form is a really nice form of the equation of a line because we get a lot of nice information. All right, let's get our information this time from a graph. So we want to talk about using a graph. So I'm going to sketch a little graph of a line here. So my axes go by ones. So I'm going to have a point on my graph. I'll plot it in a different color. There's a point on my graph, and there's a point on my graph. And my line's going to go through those 2 points. Like so. Yes. And we want to find we want to find the equation of the line in slope-intercept form. Oh, thank you. Well, from my graph, the y-intercept is what? -2. B is -2 because the graph crosses the y-axis at the point 0, -2. For the slope, we're going to count rise over run. So my rise from -2 to +2, I'm going to count 1, 2, 3, 4 over, and from -2 to 2, I'm going to count over 1, 2, 4 over 2, which is 2. So B is -2. I found that from looking at my graph. The slope, I can count the rise over the run between those 2 points. And my equation is y equals 2x minus 2. And I could check my work. Let's plug in a point. What is x here? 2. Plug in 2. Y equals 2 times 2 is 4. Minus 2 is 2. I get the right point that's on my graph. So I can check to make sure I have the right equation, because my points that are on the graph have to work in that equation. So from a graph, I can find the y-intercept by looking at where my graph crosses the y-axis, and I can count rise over run to get my slope. And if my rise, if I have to go downhill, if I have to go down to get to the next point, my rise is going to be negative. That's how I get a negative slope. All right, questions there? Hopefully some of this stuff is ringing a bell, because I know in previous math classes you worked a lot with slope and graphing lines and that kind of thing. I remember when my son was in middle school, he said, "Dad, I'm so tired of talking about lines and slopes." All right, what if we have 2 points? So we want an equation of a line that goes between the points 1, -6, and -3, 10. Well, we know we can find the slope because we have our nice formula. M is y2 minus y1 over x2 minus x1, our slope formula. So I can find my slope. So I'm going to label my points: x1, y1, x2, y2. Be good to write some of this stuff down. That's a good plan in math class, Manny. Writing things down, good plan. I'm going to plug my numbers in here. y2 minus y1, 10 minus -6, over x2 minus x1, -3 minus 1. 10 minus -6 is 16. 10 plus 6. -3 minus 1 is -4. 16 divided by -4 is -4. Now I'm going to write the equation of my line. I have y equals -4x plus b. And now I'm going to plug in a point to find b. And I can pick either one of these points. I'm going to pick this one because this 6 is smaller than 10. That's the only reason I'm picking these. So I plug that point in. I get negative 6 equals negative 4 times 1 plus b. Well, negative 4 times 1 is just negative 4 plus b. Add 4 to both sides to get b by itself. These go away, and I get b equals negative 6 plus 4 is negative 2. So I have my slope is negative 4. I have my y-intercept is negative 2. So my equation is y equals negative 4x minus 2. And I could test to make sure that my answer makes sense by plugging in one of these points and seeing if that works. Yes?
Sorry, I'm a little confused for negative 6.
Right here.
Right.
I plugged in this x and this y into this equation.
Okay.
So here I can do this. And I could pick the other point if I wanted to, and I'd get the same answer. I just pick one of the points. Maybe I'll label the point 1, negative 6. Plug in point 1, negative 6 to find b. So there's my equation, y equals negative 4x plus 2. I could check. If I plug in x equals 1, negative 4 times 1 is negative 4, minus 2 is negative 6. And my answer checks out. Yes? Yes, you would get the same answer. It comes out the same no matter what you do. All right, let's go the other way and make a graph from a line. We came up with our equation from a graph. Now let's make a graph from our equation. So let's say we want to graph y equals 2x minus 1. Now if we have our equation in y equals mx plus b form, it's nice because we don't have to make a table. So I know my slope, my rise over the run, rise over run equals 2, and I know that b equals negative 1. So what I'm going to do is start my graph at the y-intercept and count spaces with my slope. So I'm going to plot my point at my y-intercept right here. And then I'm going to count rise over run. I can think of 2 as being 2 over 1. And I'm going to count 2 over 1 to get to the next point. So I'm going to go up 2, 1, 2, and over 1. And there's my new point. And if I wanted a third point, I would go up 2 and over 1 to get my third point. And now I can connect those in a nice line. And there's a graph of that line. It has a y-intercept of negative 1 and a slope of 2 over 1. Rise over run is 2 over 1. So if we have y equals mx plus b form, we don't have to make a table of values. All right, questions there? Yes? So I started at my y-intercept, So we know it crosses the y-axis at -1. And then I know my slope is 2 over 1. So I counted, for my rise, I counted up 2. And for my run, I went over 1. And then to get the next point, I counted up 2 and over 1. So I could write on here, count up 2 over 1 for rise over run. All right, last example. We're going to make a linear equation from a description. So let's say we're hiring somebody to do some kind of work on our house or something, and it costs, guys, knock it off. It costs $45, a flat fee, plus $30 per hour. We want to write a linear equation to model this situation. So the guy says, well, it's going to cost $45 for me to come out, and then I charge $30 an hour. We had a guy the other day, a few weeks ago, install a light way up in a vaulted ceiling, and it says, well, it costs this much money for me to get my scaffolding out of storage, plus this much money per hour. Same kind of thing. Well, let's say y is our cost, and x is the number of hours. So our cost is going to be $45 plus $45 plus 30 times the number of hours. And I could rewrite this. I could say that's the same as 30x plus 45. And that would be an equation that modeled the cost of this whatever job that we're doing would be. And if we wanted to graph this, we'd plot a graph. Our y-intercept would be 45, and our slope would be 30. So we'd have to make sure we labeled our x and y-axis appropriately to be able to get these numbers on our graph. All right, questions? Yes?
So you could do it either way?
Yeah, either way is fine. Usually when we write, well, I just wrote it this way because this shows us y equals mx plus b. It looks like that way. All right. Our homework today. We're in section 5.3. And we're on page, whoops, I forgot to write the page number down.
Oh my God.
Yeah, the numbers are there, but the page number isn't there. All right, give me a second here. I will get that. This is page 312. All right, there we go. 10 minutes.